Space is beautiful, a canvas of swirling nebulae and distant twinkling stars, a cosmic ocean of possibilities, but it's also terrifying. Out there, beyond the familiar embrace of our solar system, lie planets that defy not only our imagination, but the very essence of what we consider habitable. These are not the gentle worlds of science fiction dreams, they are cosmic nightmares made real. We speak of planets that rain molten glass, driven by winds faster than any hurricane Earth has ever known. We speak of planets hotter than the surfaces of some stars, where elements we consider stable simply vaporize. These are worlds so extreme they make mythological depictions of hell look like a tranquil holiday destination. They are the universe's grand, indifferent experiments in extremity. Today we embark on a journey to the edges of existence. These are the top 10 deadliest planets ever discovered. Real places confirmed by our telescopes, lurking in the vastness of the Milky Way. Worlds where survival is not just unlikely, it's a cosmic impossibility. Prepare yourselves as we explore the most inhospitable corners of our universe. Our first destination is 55 Canankree E, a planet that orbits a star much like our own sun, yet it exists in a realm of unimaginable torment. It's classified as a super-Earth, a term that might conjure images of a larger, perhaps even more bountiful version of our home, but let this name not deceive you. This world is no terrestrial paradise. Imagine a year that lasts a mere 18 Earth hours. This frantic cosmic dance places it perilously close to its sun, subjecting it to an unrelenting bath of radiation and heat. The surface of 55 Canankree E is believed to be a global ocean, not of water, but of molten lava. Temperatures here soar to thousands of degrees Celsius, easily high enough to melt any metal known to humankind. Compounding this planetary nightmare is the phenomenon of tidal locking. This dayside is a landscape of pure, incandescent horror, a place where the very rock beneath your feet would be a flowing, molten river. There's a tantalizing theory that deep beneath its scorching surface, the immense pressures could crystallize carbon into vast quantities of diamond. A diamond planet, a treasure beyond imagining, yet this treasure is guarded by an environment so hostile, so utterly unforgiving that it remains forever beyond our reach. Next we venture to HD 189733b, a gas giant that from a distance might lull you into a false sense of familiarity. It presents itself as a beautiful deep azure orb, strikingly similar in color to our own tranquil Earth as seen from the depths of space. This captivating blue hue, however, is a cruel deception, a cosmic siren song luring us towards unimaginable peril. The mesmerizing blue of HD 189733b doesn't come from serene oceans of liquid water as it does on Earth. Instead, its atmosphere is laced with silicate particles, the very building blocks of sand and glass. These particles scatter blue light, creating the planet's alluring appearance. But these are not gentle, hazy clouds. They are the ingredients of a storm unlike anything we can conceive. For on this seemingly beautiful world, it rains. Not water, not even acid, but molten glass. Imagine tiny shards of superheated glass forming in the upper atmosphere and then hurtling downwards. This is not a gentle shower, it's a deluge of razor-sharp incandescent projectiles. And if the molten glass rain wasn't terrifying enough, consider the winds. HD 189733b is racked by winds screaming at nearly 7,000 kilometers per hour. That's more than 20 times faster than the most powerful hurricanes recorded on Earth. Prepare yourselves, for we now journey to Kelt 9b, a planet that doesn't just flirt with stellar temperatures, it surpasses many stars themselves. This is unequivocally the hottest planet ever discovered by humanity. Its existence pushes the boundaries of what we thought possible for planetary bodies, challenging our understanding of celestial mechanics and atmospheric physics. Kelt 9b is a gas giant, significantly larger than Jupiter, but its sheer size offers no protection from the cataclysmic heat it endures. Its surface temperature, or rather the temperature of its upper atmosphere, reaches a staggering 4,300 degrees Celsius. To put that into perspective, this is hotter than the surface of many red dwarf stars, the most common type of star in our galaxy. This extreme temperature is a direct consequence of its extraordinarily close orbit to its host star, Kelt 9, which is itself a behemoth, a hot blue A-type star, much larger and hotter than our Sun. Kelt 9b completes a year, a full orbit around its star in just 1.5 Earth days. Under such extreme conditions, the very atmosphere of Kelt 9b is boiling away into space. Molecules of hydrogen, helium, and even vaporized heavy metals are being stripped from the planet at an astonishing rate, forming a vast comet-like tail trailing behind it. If you could somehow impossibly step onto Kelt 9b, you wouldn't merely burn or melt. The concept of burning implies a process. Here, the energy is so intense that you would simply disintegrate. Chapter 4, WASP 12b, the egg-shaped planet in a cosmic death spiral. Our next subject, WASP 12b, offers a different kind of horror, not just of extreme conditions, but of a slow, inexorable demise. This is a planet that is actively being devoured by its own star. WASP 12b is a hot Jupiter, a gas giant orbiting incredibly close to its parent star. This proximity results in immense tidal forces, the same kind of gravitational pull that causes tides on Earth, but magnified to an almost unimaginable degree. These forces are so powerful that they have distorted the planet from a sphere into a distinct egg shape, its elongated end pointing towards the star that is its doom. The star's gravity is literally tearing WASP 12b apart, stripping away its atmosphere at a prodigious rate, something like 6 billion metric tons per second. This material doesn't just vanish, it's pulled into a swirling disk around the star, a cosmic accretion stream, as the planet is slowly unraveled, layer by layer. Astronomers refer to this process as a death spiral. WASP 12b is not just losing its atmosphere, its orbit is decaying. Chapter 5, TRES 2b, the planet of eternal night. We now journey to a world shrouded in an almost absolute darkness, TRES 2b. This exoplanet holds the distinction of being the darkest planet ever discovered. While other worlds on our list terrify with their heat or violent weather, TRES 2b instills a different kind of dread, the horror of perpetual impenetrable gloom. TRES 2b reflects less than 1% of the starlight that falls upon it. To put this into context, fresh asphalt reflects about 4% of light, and even black acrylic paint reflects around 5%. This planet is darker than coal, darker than any substance naturally found on Earth. The reason for this extraordinary darkness remains something of a cosmic mystery. Scientists speculate that its atmosphere might be laden with light-absorbing chemicals, perhaps clouds of vaporized sodium and potassium, or exotic titanium oxide compounds that simply don't reflect light in the visible spectrum. Imagine standing on TRES 2b, or rather floating within its upper atmosphere. Even with its host star relatively nearby, the environment would be one of profound, disorienting darkness. You wouldn't be able to see your hand in front of your face. Any light source you brought would be swallowed by the oppressive gloom, its beams struggling to penetrate more than a few feet. Chapter 6, Gliese 436b, the world of burning ice. Our next destination, Gliese 436b, presents us with a paradox that seems to defy the fundamental laws of physics as we commonly understand them. It is a world where ice doesn't melt under extreme heat. Instead, it burns. This is not a figure of speech, it's a description of a bizarre state of matter known as hot ice, or more scientifically, exotic high-pressure water ice phases. Gliese 436b is a Neptune-sized planet orbiting a red dwarf star. While not as intensely hot as some planets on our list, its surface temperature is estimated to be around 439 degrees Celsius, certainly hot enough to vaporize water under normal terrestrial pressures. Yet, observations suggest the presence of significant quantities of water, not as steam but as a solid. The answer lies in the immense gravitational pressure exerted by the planet's mass. Chapter 7. PSR-J 1719-1438b, the Diamond Planet in a radiation inferno. Behold, PSR-J 1719-1438b, a planet that could be the ultimate cosmic treasure, a world believed to be composed almost entirely of crystalline carbon. Yes, a planet made of diamond. The sheer thought of such a celestial body, a sphere of glittering, ultra-hard diamond, staggers the imagination. But before you start planning your interstellar mining expedition, consider the neighborhood. This diamond world doesn't orbit a benign sun-like star. Instead, its gravitational master is PSR-J 1719-1438, a millisecond pulsar. A pulsar is the incredibly dense, rapidly spinning corpse of a massive star that has exploded as a supernova. It's a cosmic lighthouse, sweeping beams of intense radiation across space with terrifying regularity. This pulsar spins hundreds of times per second, emitting focused jets of high-energy particles and electromagnetic radiation. PSR-J 1719-1438b orbits this stellar zombie at a very close distance, completing a revolution in just over 2 hours. This means it is constantly, unremittingly bathed in a lethal flood of X-rays, gamma rays and charged particles. Living on this diamond planet, or even approaching it, would be akin to trying to survive inside an active microwave oven. Chapter 8. Kepler 70b, the Phoenix planet forged in a star's heart. Our next candidate for the deadliest planet is Kepler 70b, a world with a truly astonishing, almost unbelievable backstory. This planet, or what remains of it, is not just orbiting a star. It used to be a star. It's a survivor of a stellar cataclysm, a phoenix risen from the ashes of its former sun, only to find itself in an even more precarious and hellish existence. Kepler 70b, formerly known as KOI 55b, orbits what is now a subdwarf B star, the incredibly hot, dense core of a red giant that has shed its outer layers. It's believed that Kepler 70b was once a gas giant, much like Jupiter. As its parent star evolved into a red giant, it expanded, engulfing the planet. For a time, Kepler 70b spiraled within the star's outer atmosphere. Somehow, against all odds, the dense core of this gas giant survived this stellar immersion. When the red giant finally expelled its outer envelope, Kepler 70b was revealed, drastically transformed and now orbiting incredibly close to the exposed, superheated stellar core. The surface temperature on Kepler 70b is estimated to reach a mind-boggling 7,000 degrees Celsius. Chapter 9, Cororo 7b, the planet of rock rain and lava oceans. We now turn our gaze to Cororo 7b, a planet that truly earns the moniker Lava Planet. Discovered by the Cororo Space Telescope, this exoplanet is a rocky world, perhaps only 1.5 times the Earth's radius, but its resemblance to our home ends there. It orbits its star so closely that its surface is a nightmarish landscape of molten rock and extreme temperatures. Imagine a world where one side is perpetually locked towards its sun, enduring temperatures that can soar above 2,000 degrees Celsius. On this day side, the very rocks that make up the planet's crust are not solid, but a bubbling, seething ocean of lava. Mountains would melt, plains would flow, and the entire landscape would be a dynamic, incandescent hellscape. The heat is so intense that rocks don't just melt, they vaporize. Silicates and other minerals are boiled off the surface, forming a tenuous, bizarre atmosphere composed of rock vapor. This isn't an atmosphere of nitrogen and oxygen, but of gaseous stone. The implications of such an atmosphere are as strange as they are terrifying. Chapter 10, HD 106906b, the lonely outcast at the edge of oblivion. Our final destination is HD 106906b, a planet that isn't deadly in the same fiery way as many others on our list, but whose existence is so bizarre and precarious that it earns its place among the cosmos's most inhospitable worlds. This is a rogue-like giant, a planetary outcast that doesn't seem to play by any of the conventional rules of planetary formation or orbital mechanics. HD 106906b is a gas giant, estimated to be about 11 times the mass of Jupiter. What makes it truly extraordinary is its orbit. It circles its binary host stars at an astonishing distance, over 730 times farther than Earth orbits the Sun. So, yeah, after that journey through the cosmic chamber of horrors, are you ready to book your interstellar flight? Perhaps not to these destinations. The universe, in its infinite variety, crafts worlds that are not just beautiful, but also profoundly violent, bizarrely alien, and unimaginably deadly. These aren't figments of a writer's imagination. These are real places, discovered by our ever-searching telescopes, existing within our own Milky Way galaxy. These extreme exoplanets serve a vital purpose. They remind us of the sheer power and indifference of cosmic forces. They underscore the incredible rarity, the preciousness of a world like Earth. Our planet, with its liquid oceans, its breathable atmosphere, its temperate climates, may not always seem perfect. It has its own challenges, its own tempests. But when viewed against the backdrop of molten glass rains, star-hot surfaces and diamond worlds bathed in lethal radiation, Earth is revealed for what it truly is, a paradise, a fragile, pale blue dot that is, for us, the only haven in a vast and often hostile universe. Thanks for watching NexTen Space. Remember to like, subscribe, and hit that notification bell for more cosmic curiosity, delivered every week.